and both of them have had a ton of whiteboard rooms.
I know, but the way he worded that made it sound like he's had like half a dozen rooms, and they've all had 50,000 whiteboards.
You're looking way too far into this, dude.
Just to give you an idea, I have been in more than 5 different classrooms. So.
And I'm guessing all of them have had a buttload of whiteboards.
Okay, I have only 2 here. All right, hey. Okay, first and foremost, let's talk about the basic structures of things I want you to know. So I'd like you to write down this first problem. This is going to be our kind of our starter intro problem.
Oh, I cannot.
Yeah, sorry.
It
I
says
should use a different color.
3x to the 2 minus
I'll say it
7.
out loud here in a minute.
That's a 7, and what's 3x to the 2?
Yep.
Okay, all right.
3x
Let me say it out loud. I'll avoid the red. Here, I wonder if I can lower this down if that will help.
That doesn't mean you can't see it.
That help?
Yeah.
It's
Okay.
just my vision.
Using red.
For red and not have
3x squared minus 7x plus 8. And that's in parentheses. And then 4x squared plus 5x minus 6. Okay. Yeah, sorry, I always forget, like that side of the room, it's like impossible to kind of see this side. So I'll remember that. I'll try to avoid red today. All right. Okay, so first and foremost, the question that we need to make sure of. Number 1, these are going to be like the first ones we're going to get in the homework probably tomorrow. They'll ask you to find the sum or difference of the following polynomials. So that means add or subtract polynomials together. Write it in descending order. That means biggest power down to smallest power. So they do want you to practice putting it in order. And then tell me the degree of it. That means the highest power of this item. If, once you've simplified. Because obviously when I look at this problem, the highest degree right now is a power of 2. But maybe they cancel each other out.
Holy cow.
So, all right. So let's add these things together. So when you add, you can just leave the parentheses off. You don't really need them at all unless you have a number that you have to distribute, which we're going to do here in a minute. But on this one, I really don't need the parentheses. I just wrote it so you can see I'm adding a trinomial and a trinomial. So let's add like terms. So the x squared terms, we're adding 3 and 4. That makes what? 7x squared. Is this easier to see for you guys?
Yeah.
That one? Okay. The blue is the better color, huh? Okay. For the x's now, for the plain x's to the first power, we have a -7 and a +5. -2. Okay. And then we have an 8 and a -6. These are the constants. Makes a +2. All right. This is the answer I'm looking for. That is called descending order. Okay, it is largest power down to smallest power in terms of x's. Question.
Do you have to put the x?
No, x the first no. No, I just put it there so you know what I'm doing. Okay, now the last question that people will tend to forget because they forget to read the directions. They want you to find the degree of this polynomial, the final polynomial. We know it's a trinomial, right? It's got 3 items. But the highest degree variable, 2. It's degree 2 because of that power right there. Okay, questions on the easy problem. I know it's simple, it's just I want to get the basics now. Question.
Can we erase the last minute on the camera?
Why?
It doesn't matter, but we could just erase it and that'd be good.
Okay, moving on. Okay.
Yeah, subtle.
So, moving on to the next part here. What we need to do next is to look at how to multiply terms together if I have a constant and I'm taking it times a polynomial, or take 2 polynomials times each other. Those are the 2 next things I want to go into. So for instance, let's go with 5 times 6x plus 2y minus 7. Okay. This is one of the problems that eventually I get to see. They're getting you used to this idea of parentheses and brackets. They're grouping symbols, and they want you to be able to add and subtract these together. So, for the first part, I would do everything inside the parentheses if I can. Well, I'm adding 2 polynomials together. This is a monomial, a single item, with a binomial. I'm trying to add them together. There's really nothing I can add, because the parentheses doesn't even need to be there since you're adding. Now, if you're subtracting, which we'll do here in a minute, you do have to make sure you have the subtraction symbol there, or the parentheses have to be there. But in this case, I really can't add anything together. There's no like terms there, So I'm going to distribute the 5 through the parentheses. It's going to go to each item one at a time. Now, here's what I need to make sure of. No matter what number's out here, you need to make sure you distribute. So this is one of the problems that confused people, I think like 2 homework sections ago. There was something like this, where the problem had one extra piece written out front, had like a 4 plus. You need to multiply first because of order of operations, right? Add, subtract, multiply, divide, those orders of operations, this is the order we're still following. Now the reason why we're still following this is because it's in an expression, it doesn't have an equal sign. So you do have to multiply and divide before you add and subtract on this particular problem. Does that make sense why I would distribute the 5 in that case? I'm going to get rid of the 4. The 4's not there. I'm just showing you that if there was a 4 out front, you have to distribute the 5, then you can do the 4 later and add. Question?
So if it did have an equal sign, it would, that doesn't matter then?
If it had an equal sign, you could go in different orders than what I have here.
You need to do sad
you could-
math.
Yeah, you'd have to go backwards through the order. You have to subtract and add first, and you have to, so it's kind of it's a weird process for how you do that. We're going to get to those later. But yeah, so we're going to multiply first. I'm going to get rid of the 4. I don't need this. I just wanted to show you that.
You're smoking
All right.
out my ears.
So multiplying the 5, sorry, I have 30 x's. I have a 10y and a 35. Now, degree of this polynomial. 1. The highest power is a 1. Doesn't matter which letter you look at, so it is degree 1. Now, if they were to happen to mix different letters together, variables, so there's x's and y's and in spots, you have to add all the powers together in certain locations. What you're basically doing is you're just finding the degree of each separate item. That's how you can tell what the highest degree is. Okay, now descending order really doesn't matter on that one because it has multiple variables. That's not something I would ever check. So, questions on the easy stuff. I'm starting easy to make sure you get.
Why did you get rid of the parentheses?
Just distributing. Once you distribute, the parentheses are gone. Yeah. Okay. We good with the first ones? Okay, let's jump a little bit in terms of difficulty now. Because I've been kind of sticking with the easy stuff. We need to actually get to the point where we need to be by the end of the day. I'm just gonna go right to it. Here we go. That green's so good. Let's go with 4 minus 2x plus 10, parenthesis, 3 minus 4x plus 5. Okay, I'm jumping right in. Okay, bless you. We are multiplying these two parentheses together. We are really stepping over the threshold here. The idea is on this problem, you still have to simplify the parentheses first. Once you've simplified these, if you can, then it makes the problem a little bit easier to look at. I'll let you write it down here because I know the hardest part is getting it written down correctly. Okay, so what it appears to look like, it appears right now currently that I have like a trinomial and a trinomial. They'll simplify. It will go down to something smaller because I have to combine like terms and whatnot inside the parentheses to begin with. Then it will be down to something that we're probably more familiar with. Questions on the start here, what we're looking at. Okay, now, on this particular problem, what we have to do first is distribute the negative sign. Here's why. This is technically a -1 that you are multiplying into this parenthesis right here. The negative sign has to be distributed. That's how you're supposed to correctly subtract polynomials. Because you are subtracting. You're subtracting this minus this item. So when you subtract, here's what we have. We have 4 minus 2x, and then -1 times 10 is -10. Now we'll go one more step here in a minute, but does that make sense how I distribute the negative sign? Notice, once you've done that, the parenthesis goes away. On the other side, same exact idea. I'm going to distribute the negative sign to everything here. So what I have is I have 3 minus 4x minus 5.
That's easy on the eyes.
Okay, questions on the distribution part? So I've multiplied technically. Now what I'm gonna do is I'm gonna combine my terms inside the parentheses. Then from there I can continue on. In here we have a negative 2x, we have a 4 and a minus 10. The constants can be added and subtracted together. 4 minus 10. Negative 6. Okay, so here's what we have. I don't really care that where you put this. Negative 2x minus 6. That's how I'm going to write it. I like to put constants in the back. So it's negative 2x and a minus 6. And we're going to multiply that in another bracket here, which if I combine these, I have a negative 4x minus 2. How I get that? The 3 minus 5. So it's negative 2. And again, if you switch them around, it's not a big deal. It's not the end of the world. I'm just writing down what I always do. Questions at all about how we got to this point? Hopefully, can everyone see it over there? Can you see that?
Yep.
Okay, now, at this point, now we're foiling. That was a word that we brought up last Friday. FOIL, first, outer, and the last, only works if there are two binomials. You're basically going the first items in each, the outer items, the inner, and then the last items in each parenthesis. First, outer, and last. It's distributing twice. That's just how I think of it, but we do have that little acronym that we say. So, negative 2x times a 4x. So let's do the first items first. Negative 2 times negative 4? 8, and then what is that, x squared? That's taking the 2x times the negative 4x, right? Positive. Outer. Negative 2x times a negative 2. Positive 4x. All right. There's the first part of the distribution. The first item times everything in the back. The next item. Negative 6 times 4x.
24.
Positive 24x, good. So that's inner. Now last, negative 6 times negative 2. Positive 12. Okay, it's like distributing twice. That's what you're doing. Doing the first item to everything, the back item to everything. Now I can combine like terms, so I would get it into descending order. So the final answer here, what I should have in the very end, I should have 8x squares, a 28x, because I'm going to add the x's together, and a 12. And there's your answer. That's in descending order, degree 2. Now there's a purpose to know why there's a degree to it. That comes up when we start graphing these by hand. To understand all the parts of graphing, which I think you probably learned the basics in Algebra 2. We're going to refresh your memory on how to do it.
You're gonna have to graph a lot this year.
No, we don't graph a lot. We just do little parts so you know how to do it. We graph probably more
We
calc.
graph literally every day.
Every single day of it.
We don't really graph too often. We do a lot of this stuff, calculations. Okay, questions at all? Does that make sense?
Yes.
Okay. The idea is that I threw something at you that probably you weren't comfortable with in the beginning. That's just something that you don't see that type of problem every day. It was just something I wanted to throw kind of something more difficult looking. Now, the last 3-4 problems I want to talk about today is Pascal Strangle, and then talk about what would be a major use of doing something like this. Now, obviously, this can be a little bit of a stretch, but I'll give you the idea of what we're doing. Okay? All right, let's go on to this next problem. So we're going to need to look at Pascal Strangle. This is the triangle where I don't want you to memorize it. I'm going to pop it up here on the board again. I don't want you to memorize this. I want you to know how we make it, right? What it is. This triangle is to help us multiply polynomials together if we were just to raise something to a different power. So our goal today is to do an example of something probably a little more extreme than the one we did on Friday. So what I mean by that is that this triangle is made by ones on the outsides. Every time you go down a rung, they're adding one more number, as you can tell. You know, 1 number, 2 numbers, 3 numbers, 4 numbers, 5 numbers, so on and so forth. And then each rung represents a degree. So degree 0, degree 1, degree 2, degree 3, degree 4, 5, and you guys get the idea. That's what these represent. Now, what the degrees are It's the power you put on a parenthesis when you're multiplying terms together. That's why this triangle is super helpful. It is a shortcut for doing crazy complex multiplication. And it's one of those things that if you were to do it enough, how this, this triangle came about is that they recognized that when you multiply terms together, multiply like polynomials together, that you're getting the same results every single time, that there's a relationship there. So here's my extreme example today, just so you make sure you guys get one. I'm going to go 3x minus 4, and let's go to the 6th power today. Okay, we'll try another one here in a minute. So I want to start with something that's a little overboard compared to what we've done before. Okay, now what this actually means, now I'm not going to do it, but what this means is that you're multiplying 6 parentheses together. That I actually have 6 of these. 4, 5, 6. Okay, we have 6 of these like this multiplied together. I do not expect you to do that. Some people will because they think that's easier. Fine and dandy, more power to you, good luck.
That's
1, 2, 3, 4, 5, 6. Okay. And now how you'd actually do that if you want to do it by hand, you FOIL the first two together, get whatever that answer is. Then you'd have to take that answer times the next parenthesis, FOIL those together or distribute, however you want to think of it. Get that answer, whatever that large answer is, you take it times the next parenthesis and you keep going and going and going. There's a lot of terms there across the board. Okay? I would not want to do that. That would not be pretty, that would definitely not be fun. So, this triangle is to help us shorten this answer out significantly. Like it's meant to make this as easy as possible. Okay, I'm going to leave this on the board. I'm going to put a little sticky note below it.
Couldn't you just FOIL the pairs and then multiply those again?
Yeah, you can do it that way too. Like there's different ways of actually doing that, yes. Okay, I'm going to put a sticky note on the board. No, wait, first, let's do it. Alright.
Take that and FOIL it on the 3x minus 4 and FOIL that on the 3x minus 4 and FOIL that on.
Be a lot of threes.
Okay. Does everyone have the problem written down though?
Yeah.
Okay. Alright. So here's what I'd like you to do. Why I wrote this the way that I did, why I put a little sticky note there, is to show you what we're doing. Okay, we are going to separate, now on your notes, you're going to separate these numbers, the 1, 6, 15, 20, 15, 6, and 1. Separate those on your paper and put a parenthesis behind each number. Now, why I picked this row of numbers is because what degree did my problem have? Had a 6 on it. That's why I'm picking that row. Now again, how they made this thing, just so you know, because this is something we talked about last Friday. The ones are on the outside. To get these numbers on the inside, they added the 2 numbers above it together that are diagonal from it. So to make the 2, they added the 1 and 1. To make the 3, they added the 1 and 2, 1 and 2. To make the 4, add those together, add the 6, the 3. And the outsides are always 1s, they're just adding another number. If that makes sense how they're making every single row. That's why I don't really memorize it. I can make it on the fly. It's just not fun when you're up in those bigger powers, you have to keep going. Okay. So far so good? Okay, now what we talked about on Friday was now that you have all these parentheses separated, all these numbers, 1, 6, 15, 20, 15, 6, and 1. You're going to put plus signs behind each parenthesis because you're going to be adding all these parentheses together eventually. Okay, now what goes in each parenthesis is based on what your original problem was. So over here, what are the items that are in my parentheses? A 3x and a negative 4. Those are the numbers that are going in my parentheses. So each parenthesis, I'm going to have a 3x and a -4, and those two numbers are being multiplied together on the inside of those parentheses. Again, that I'm getting them from these two things. Even if they're positives or negatives, I use those numbers. So, and they're being multiplied in each parenthesis.
Then you start with 6 and 0 and then.
Yeah. We'll get to that here in a minute, yes. Okay, does everyone understand how we're doing this so far? Because those terms are, they're each one that you'd FOIL, eventually they'd be multiplied together. So, because when you actually FOIL, you're doing a lot of multiplying, that's why they actually have one. Okay, does everyone understand the setup? Now, if you didn't hear Knutson here, he already talked about what we're going to do with those numbers, the 3x and the -4, is that you're going to work with powers on them. So, on each of these numbers, you're going to be, one of the powers is going to be counting down, one of them is going to be counting up. And how I do this, the first item in the parenthesis, the 3x, will have the biggest power. The -4 will have the smallest power possible according to this chart. So what's our biggest power we have up here currently? The 6. So the 3x will get the power of 6. The -4 will get our smallest power. What's the smallest power up here? Degree 0. Okay? That's how it works. It's whatever problem you're working with. It's the highest degree and the lowest degree you can possibly have without going negative. So 6 and 0. Now, as you go down, the 6 is going to count down. The 0 will be counting up in power. So it's going to keep counting down. The other one counts up. One counts down. The other one counts up. One counts down. The other one counts up. And so on and so forth until you get to 0 and 6 on each one. Now, this is where your calculator is going to be your best friend. So if you need to go grab one, I would suggest you go get one for me. They're in the back, they're underneath the little basket. Yeah, if you want to put them on the top there, they're right behind the cell phone caddy. Yeah, just put them on the top there. I got 10 of them, I think. Yeah.
I kept getting mine
You broke my bed.
Oh, don't say that.
Come on.
Okay, all right. Hey, shh. Okay, all right. So here's how it works.
No, seriously though, like my bed is sitting my head.
Okay. What is -4 to the 0 power? A 1, right? So this is a 1. We're going to take it times. What is 3 to the 6 power? Say it again?
729.
729. That's, and we have an x to the 6 power because both the 3 and the x would both get the power of 6. So 3 to the power of 6 would be 729, and we take that times the 1 out front. So the first parenthesis is ending up being 729 x to the 6. That's the first answer you'd get if you were to FOIL all 6 of these parentheses out. That's the beauty of it. It's giving you your final answer. You just have to know how to type it in your calculator. Okay, let's go to the next item. -4 to the first power is a -4. We're going to take this 3 to the 5th power. So what is 3 to the 5th? 343. Thank you. 243 x to the 5th. And then we're going to take that times 6. So what do we get when we take 6 times 243 times a -4? Well, number one, you're going to get a negative number. Because it's -4 times 6 times 243. 5,832. Okay, x to the 5th. All right, is there any questions with how I'm coming up with these numbers? Say it again. Times 6 times a -4. The x has a power of 5. That's how we got the 243. It was 3 to the 5th power, x to the 5th power. Oops. Okay, all right. Are we good so far? These are questions we got to figure out, because obviously I threw in the deep end with this one.
You love it when students just go, oh.
I do like that, because you're figuring out. Look. Yeah. That's when I know you kind of finished.
It's
All
just
right,
like completely.
let's go to the next
and
one.
then it's a
Okay,
dimmer
on the next one, we're going -4 to the second power, which is 16 positive 16, because the negatives will cancel. 3 to the fourth power, which is 81, x to the fourth, and we're going to take that times 15. That is a very big number. 440 x to the fourth. So 19,440 x to the fourth power. Again, that's -4 to the second power, which is 16 positive 16. We took that times the 81, which is 3 to the fourth power. And then we took that times 15, which is a really big number. Okay, questions at all so far? Is everyone still clicking with me, like where I'm getting these numbers from? I'm using those powers to figure out these huge numbers. And calculators, obviously. All right, let's go to the next one. -4 to the third power. That should be a -64, I believe. And then, it's negative because it's power 3. 3 to the third power is 27x to the third. And we're going to take that times 20. So we're taking 20 times 27 times the 64, which is an insanely big number.
Negative 34,560.
160x to the third. Yeah, because 20 times 27 is 540, and then you take that times 64, which is 34,000. Big numbers.
Do these in your head, Word.
I could, but it'd take me a while. All right, go to the next one. -4 to the fourth power. That's 256 positive. We're taking that times 9x, and then we're going to take that times 15. So, 15 times, 9x squared, sorry, 9x squared. And then a -4 times 4.
What are you doing?
Is my 256 right? I don't know if that is right. That might be like 216, I have no idea. What's 4 to the fourth power?
256.
Is it 256?
Yeah, but you get like the same number. 34,560.
Okay. So, it's positive 34,560?
Yeah.
Yeah, that's just weird.
That is weird. Okay, we'll go with it. Okay? And then, let's go to the next part here. So that's, so that was that term. The next one, 4 to the fifth power. So 4 to the fifth power is a 4 carry a 2. That's a 2 carry a 4. Was it 824? I have no idea.
For -4 to the third.
Yeah.
It's going to be 1,024.
1,024? I was way off. I didn't carry a 2. All right. So 1,024, that's negative, times 3x times a 6.
18,432.
Negative 18,000 what?
432.
32x. Okay, is everyone still following with me how I'm getting that number? That was a -4 to the fifth power, which is that negative 1,000 number, times the 3x, times the 6. They're all being multiplied together. And the last item is -4 to the sixth power. It's going to be positive. And 4 to the sixth power is a 16, carry a 1. That's a 9. That's a 0 and a 4, 4,096 times 1 times 1. 3x to the 0 is a 1 times 1. So it ends up being a 4,096.
That's your final answer.
And that's your final answer. This thing, what you're getting right here, this monster of an answer. That's the result if you were to FOIL all 6 parentheses out in the long run and simplify all the terms. Now, obviously, I threw you in the massive deep end there. Like, I threw negative numbers at you, I threw a huge power at you. Power 6, I consider that huge in terms of parentheses. I think the biggest one we did the other day was 4. And they still grow. Like, look at this. This is a power of 6, and you're getting numbers like 34,000.
So what's the biggest one you've ever done with the Pascal's Triangle?
For me, in college, I remember doing one with power 15.
Disgusting.
Yeah, it was pretty bad.
I feel like 40.
But the problem is, typically that was like one. We do one, it was like easy, I had twos. It was kind of straightforward. The ones that are super difficult that I remember having to do was take this type of problem, you know, with Pascal's Strangle, but use a trinomial instead.
How does that work?
You have to group it. So you have to do like, you have to group like a single item and a binomial. So like you take a trinomial and break it up into like 1 versus 2 parts. And those, like the 1 and the 2 parts here, that's your 2 parts that you're putting here and here each time. So in the middle of this problem, you'd have to actually do Pascal's Triangle again.
Disgusting.
No thanks.
Once you get it, you're like, all right, that was pretty good.
What?
I don't think I'll ever sign up for that work. Ever.
All right. Now here's the thing. I knew I went through that really quick. I didn't really give you a lot of time to process that. It's that each item you have here, you have 3 numbers being multiplied together. Where the beginning numbers are from, they're from this chart. That's where the 1, 6, 15, 20. Everything else is made from the 2 parts of your parentheses and then just the powers on them. And keeping track if it's negative or positive, that's the hard part. Is knowing what a power would do. Like odd powers keep negative signs. That's why like on this term here, this had a power of 1, kept the negative sign. On this one, this is an odd power, kept the negative sign. This one had an odd power, kept the negative sign. But everything else cancels because they had even power. So keeping track of like what those numbers are. I think in the homework, I think the biggest one I think I assigned you was power 4. Pretty sure. I didn't go past that. There was a couple in the book, I think, with powers of 7s and 8s. I did not want to do that. They're big enough as it is doing a power 4. All right, now here's my question to you. Do you want me to do another one with Pascal's Triangle, or should we just save it for tomorrow? Tomorrow, okay. We'll do an easier one tomorrow, one that's closer to your homework. Now, the last thing I want to talk about, just this is my last topic, is why do we multiply polynomials? The main concept of why we do it is because of area and volume. So going back to kind of a geometry topic, area is made from like, let's say we're doing a rectangle. It's taking the length and the width multiplied together. Well, what we do in this class, what we look at, is let's say you're putting in a deck, this is a deck on your house, and you're going to put a pool in the middle of it. Okay? So you're going to put a pool, so the pool is in the middle, and the idea is that, the question is, what's the area of the deck and how much wood we need for it? Well, if you know what each board takes up an area, each board itself, well, I can tell you, once we find the area, I can tell you the minimum number of boards you need to go buy. Now, it won't be perfect, that'll be minimum, because obviously you're not going to use a full board right here. You're going to use parts of them, you're going to have to cut some. But this gives you an idea of like how to estimate a cost of a project just to begin with, like an initial cost. Because that's what a contractor would do, right? They'd look at a project and go, okay, well, you're probably looking at about 15 to 20 grand worth of wood or whatever, thing. And how they're pulling up these numbers really quick, because they're just going to look at the area. They know what an area of one board is that they can buy, and they'll go, okay, this is the minimum number of boards you need to have, and then obviously labor, but that's an idea. That's how they can get you quick cost analysis. Well, that's the concept. Multiplying polynomials is taking a length times width. That's what you're doing. Now, the dimensions are really weird because of what you have. Obviously, you'd be subtracting out parts in the middle, and that's what you'd be looking at. So tomorrow, what we're going to focus on, I'm going to do an example of area and volume, kind of with polynomials, kind of something easy. I'm not going to do the project where I throw like a deck at you yet. We're going to do a couple of these, simple ones, smaller powers, to make sure you get the right answer. And then we'll do a couple more with just regular polynomials. Get the idea? Yes. Tomorrow, bring some form of a textbook. You bring your hardcover text. You bring your online version, because I know a lot of you have been using that now. The small ones, we'll get you a copy of the online version.
You got the cease and desist yet, Ward?
Here you go.
Not yet.
Why?
Don't show you. I do.
Now you have to
Yeah,